Okay, we're continuing on with part 3 of section 7.3. And we had done only one example regarding the use of substitution, where we use one variable described in terms of another and use it in the next or the remaining equation, linear equation. So here we're going to still continue with substitution method. And we've got one listed, so we're in good shape. This is in identity form. It says y can be described as 2 times x plus 7. So we have an identity for y. So let's look at that. We're going to use that in the next equation. So we're going to use the y and replace it with 2x plus 7. And in parentheses too, because we have to use the distributive property of multiplying by -1. And we talked about distributive property in the previous example. So I'm going to have a -2x and a -7 equal to 5. Now I'm going to combine like terms. Well, we've got a problem here, Houston, because 2x minus 2x is 0 x's. So I have a -7 equal to a -5. That is false. Had it been true, we'd have had all solutions, but this is false. Therefore, there is no solution to this system. Of equations. There is not a communal answer that'll work for either of the items. And if you can see that we have, in this case, the same problem with the same slope. So these are parallel lines. Because if I move the 2x minus y equals -5, and I subtract the 2x, I'm going to have this zeroes out. So I'm going to have a -y equals -2x minus 5. Well, then I have to divide by the -1, and that gives me y equals 2x plus 5. My slope is 2. And in the first one, this is for the second equation. For the first equation, it's also 2. So that's why there's no solution. And the b's are different. All right. So now we're looking at solving equations by method 3, addition method. This one relies on LCM, least common multiple. So we need to find the number that works to be the same in one of the variables. And then it works on, that's number 1. And the second that it works on is additive inverse. In other words, if I have an A and I subtract an A, they're gone. It zeroes out. All right. So our first step in using addition method, select a variable, either X or Y, one of them, to remove. We're going to remove it. Okay, so then find the LCM required to zero out that variable. Multiply the entire linear equation by the multiple needed. Being sure that variable selected zeroes out. In other words, assigns opposite signs. So one of them might have to be multiplied by a negative multiple to make sure that you zero out one. Add vertically. And solve for remaining variable. Use solution to substitute in one of the linear equations and solve for missing variable value. And of course, we're going to use our calculator to check. All right. Seems like a lot of work. Remember, you can halt this and make sure that you get the notes that you feel you need. All right. Now, the examples might make sense of it. Now, this one is easy because in first linear equation, y is positive. And in second linear equation, y is negative. So they'll zero out. Of course, this one's the easy one, so that I can show you what I mean. All right, so I have x plus y equals 6. X minus y equals -2. All right, these zero out because they are additive inverses. Okay, because they're additive inverses, I'm going to have x plus x is 2x equal to 6 minus 2 is 4. I'm going to divide by 2, then x is 2. This is one solution. So, what I'm going to do now is use it I'm going to use x equals 2 in one of the linear equations. All right, here I go. So I have x plus y equals 6. I'm going to put 2 for x plus y equals 6. Therefore, if I subtract the 2, I have got y equals 4. So, tentative solution is the ordered pair 2, x is always first, and 4. Now I'm going to check. And now I'm going to use the x minus y equals negative 2. All right, so let's see what I have. So this is going to be 2 minus 4 equals negative 2. Negative 2 equals negative 2. That one is correct. I didn't even have to use a calculator. All right. Now that was an easy one with the steps without an LCM. So let's look at this one. First off, we have to change to look like ax plus by equals a constant. So I have y equals 2 minus 3x. I'm going to add 3x to both sides. When I do that, I get 3x plus the y equals 2. All right, and now I'm going to put the other one. 6x plus 2y equals 7. All right. Okay, so I notice that I've got 2 y's. I need a 2 here, and I'll get rid of that one. So I'm going to multiply this by negative 2, the whole thing. So I'm going to get negative 6x, negative 2y equal negative 4. And then I'm going to put this one down. 6x plus 2y equals 7. I'm going to add. This is 0 and this is 0. Does 0 equal 3? No. Well, then there is no solution because they are parallel lines. We know the slope is negative 3 there, and when I move that over, it'll be negative 3 on that one. All right. So, there you have it. I am done. There could be some more examples I could use, but I think I've given you everything you need. The last part of the homework, you can use any method you want. Any method you want. Thank you so much for listening.